Hi everyone, I'm going to go over the basic trigonometry ratios today. So starting with the right triangle. As many of you already know that trigonometry ratios, the basic ones will only work with the right triangle. The triangle that contains right angle, which is 90 degrees. So I'm going to call this A, B, C. So the basic trigonometry ratios, there are three types: sine, cosine, and tangent. So actually the longer name is sine, cosine, tangent, but we called it sine, cosine as COS, tangent as TAN. So let's talk about the names on the right triangles, names for the sides. So let's say you are looking at one angle, either B or C. We're not talking about, we could talk about the A, the right angle, but in general, we're going to talk about B or C as the angle that we're looking at. So let's say you have angle A, angle C, which is that one, and we're focusing on that angle, then I'm going to call that theta. So this symbol is for the angle. It's a Greek letter and it's called the theta. Then the name of the sides, the legs we call that, depending on which angle that you're looking at in a right triangle. So let's say it's the side AC contains the right angle and the theta that we're looking at. So we call that adjacent. And the other leg, which is AB, so side AB, is opposite to the angle theta, so it's going to be opposite. And we are left with the one last side on the right triangle, which is BC, and that is opposite to the right angle, so that's called the hypotenuse. Okay, so this side, the hypotenuse is fixed because we're not changing the right angle on a right triangle. So this side, the longest side, is, as you can see, the longest side of the right triangle is always called hypotenuse. But the opposite or adjacent can be interchangeable by looking at, or depending on which angle that you're looking at. So let's say, using the same triangle, say A, B, C, if you are looking at the angle B instead this time, so this is, I'm going to call that theta, then our adjacent will be now here, the side AB, because that one contains the angle theta and the right angle adjacent. And now the opposite is going to be the side AC. And once again, the longest side, the last one, is always hypotenuse. Okay, so just make sure you are you're aware of which angle you're looking at to come up with the ratios for the right triangle. Okay, so now let's go back into the ratios themselves. So sine, theta, the ratio is opposite over hypotenuse. Cosine theta adjacent over hypotenuse. And the last one, tangent theta is going to be opposite over adjacent. Okay, so it looks very complicated to remember, but I'll show you how to quickly memorize these 3 basic trigonometry ratios so you can apply to the problems. So sine opposite of a hypotenuse. So how we remember is using just the first letters. So we can come up with so, as sine is opposite over hypotenuse. Cosine, same rule, same way. So which is cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So how we remember? SOHCAHTOA. So that's how you remember. So let's apply these ratios into examples on next page. Before we start, whenever you're doing trigonometry problems, make sure you check your calculator is in degree mode, unless your questions ask you to write the answer in radian. So make sure you check your calculator. So we're going to do 3 examples. So here's example 1. So we got a question, right triangle. So we're given with the 2 sides. So we're given with 9 centimeters, which is a hypotenuse, 8 centimeters, one of the lengths. And what we're trying to find is this angle. So I'm going to label it with theta. So this is a question. The question is asking you to find the unknown angle. So before going into the ratios formulas, we're going to label the given size. So like I said, 9 centimeter is called hypotenuse. I'm going to call that HYP, which is hypotenuse. 8 centimeters is the side contains a right angle, and the theta, so that's the adjacent. So we're going to use hypotenuse and adjacent. So if you remember the SOHCAHTOA, let's write that over here. SOHCAHTOA, which ratio contains the hypotenuse and the adjacent, which is cosine. So we're going to use the cosine to find the angle theta. So let's do that. Okay, so cosine theta is adjacent over hypotenuse. So start with the formula, or start with the ratio. Cosine theta, so I'm going to keep the theta as the angle unknown, and we're going to replace the adjacent and hypotenuse with the given information. Adjacent is the 8 centimeters, so 8. Hypotenuse is 9. So if you can punch these numbers, 8 and 9, so put that into the calculator, and you should get cosine theta is 8 divided by 9. That will be 0.888, and this continues. I'm going to put 3 dots, and then we're going to find the theta, and that's will give us the answer. So how do we find the angle? This one you'd have to use this symbol, cosine, and then there is a little number on the top, -1, -1. This means it's called the inverse cosine, which means you're finding the angle using the ratio. So it's called the inverse cosine. You don't call that cosine to the power of -1. That's wrong. You call that inverse cosine. And what we do is we're going to put 0.888, that value, into the bracket of this, 0.888. So if you do that, we will get 27.27. So I actually rounded to the 2 decimal places, and that's it. And make sure you put the unit at the end. Theta is the angle. This one is in degree mode, so you should have a degree sign on the top right corner. Okay, that's how you do the example 1, finding the angle when you're given with hypotenuse and adjacent. On the next example, we're going to do another one, finding the angle, but this time will be a different ratio that we're going to use. Okay, example 2. Right triangle. This time, this is the unknown, the angle, and that is given information. Okay, so let's do it a little faster this time. So 12 centimeter is hypotenuse. 9 centimeter is opposite to the given unknown angle, so it will be opposite. So remember, SOHCAHTOA, which ratio has the hypotenuse and opposite? This time is the sine. So starting with the ratio, sine theta is opposite over hypotenuse. So sine theta is 9 centimeters over 12. And 9 divided by 12 is 0.75. So theta is, once again, we're taking the inverse of the sine, so which means we're going backward to find the angle using the ratio. So you put 0.75 into the sine inverse function, and you have to use a calculator. Make sure your calculator is in degree mode. And second sine, and that gives us 48.59, and that's in degrees. Okay, so that's how you find example 2, or solve the example 2. Last one, example 3. This time we're going to do something different. Once again, right triangle. This time we are given with the angle. We're given with one angle. This is the angle that we're given, and we are given with one side. This one is 4 centimeters, and the other side, the other leg, is unknown. So I'm going to call that X. So the steps are similar. So we're going to label the legs. So 4 centimeters is the adjacent to the 55 angle. So let's call that adjacent. And X, the unknown, is the opposite to the given angle. So we call that opposite. So this time you're given with the adjacent and opposite. So it will be tangent that we're going to use to solve for X. So tangent theta, so just writing the ratio for tangent, is opposite over adjacent. We're given with the angle theta, which is 55. We're going to replace the theta with 55. Opposite is the unknown X. Adjacent is 4 centimeters. So we call that 4. So here it the fraction has the unknown on the top, so we won't be able to use the calculator to figure out x over 4. So here's a little trick. When you're given with this kind of form, we're going to make the tangent 55 as over 1. And then we're going to apply cross multiplication, which means we're going to multiply this way to manipulate the equation. So what do we get? 1 times x, that's x. Or let's write it. 1 times x is equal to 4 times tangent 55 degrees. So 1 times x is just dx. So what you have to do, punch the right side of the equation into the calculator. So 4 times, what is tangent 55? Is 1.428. And multiplied by 4 is 5.71. Approximately. Okay? So the unit is centimeters. So that's approximately. And these are all approximately. Okay, so those are 3 questions, 3 examples that I wanted to go over today. So thanks for watching. Next time we're going to go over special triangles that we can apply basic trigonometry ratios. And if you have any questions that you want me to go over next time, make sure you send it to our email. Thanks for watching.